Much, Victor.
Yeah. Good day, everyone. My name is Victor. I'm an hardware design engineer. Basically, I design intelligent systems. My talk today is on securing embedded devices in robotics and IoT, thereby bridging the gap between innovation and security. What are embedded devices? Now, these devices, they are found in different sectors. They are used in different sectors, like the healthcare sector, manufacturing sector. They are basically like the brain behind the work that these robots or Internet of Things devices applications do. With the rise of technology advancements, we need to secure these devices. Now, on the other hand, Internet of Things refer to a network of interconnected physical devices embedded with sensors, software, and other technologies that enable them to collect, exchange, and act on data over the Internet. So Internet of Things is basically collecting, exchanging of data over the Internet and acting on those data. What issue are we trying to address? Now, despite the importance of these devices, they are poorly secured, thereby making them easy targets for cyber attackers, therefore leading to breaches, leading to data loss, and in critical cases, physical harm. Our aim is to close the gap between innovation and security and try to understand these threats and find ways to mitigate against them. Now, why is securing these devices important? Like I said, they are very attractive for cyber attackers because of their nature. They are very vulnerable. It comprises of both the hardware, the firmware, and the network protocols. So, some examples could be, let's use the healthcare sector as an example. So in the healthcare sector, you could see maybe someone is trying to have access to a patient's record and unauthorized access to a patient's record due to multiple login attempts. In the manufacturing sector, someone is trying to have access to the sensitive data, like the sensors data, or trying to manipulate a robot, and which could lead to a patient, which could lead to a harm of someone working there. And in some cases, they could even shut down the production cycle because of a cyber attack, or in critical infrastructures like the railway system where they use the Internet of Things. Someone can try to gain access to sensitive data. This could lead to potential delays for travelers. So these are the potential risks with Internet of Things and robotics. Now, we want to understand these challenges. Now, for the hardware side of things, someone could try to gain access to these devices, or by physically tampering with them and gaining access to sensitive data. For example, like an IoT embedded camera, someone could try to plug in a circuit and try to get sensitive data. For the firmware and software vulnerabilities, things like weak passwords, weak encryption, this could be exploited if not properly secured. Then communication protocols like the Wi-Fi and Bluetooth, which Internet of Things rely on, if not properly encrypted, it could be intercepted. Real-world scenarios, like I explained earlier, I talked about, I gave an example about a robot in the manufacturing sector, someone trying to manipulate it from a remote outside of the building, or maybe in the healthcare sector, someone is trying to gain access to a patient's record, or a smart home Internet of Things device hijacking, like someone is trying to have access to, manipulate the devices in someone's home, like raising the temperature of the thermostat, switching on and turning off lights, or even get access to sensitive data. So what are the security strategies we could adopt to mitigate against these cyber attacks on embedded devices? One of them, during design phase, we could we could build security into the design phase by using the hardware root of trust method, such that any device that is connected to this system, it has to be authenticated. It has to be verified before it can be used within the system. During the development stage, we could use secure coding practices and regular updates. Then during the deployment stage, we could use continuous monitoring of anomalies. Anomalies are things that is basically used in machine learning or AI. Things that are not regular. They are different from the normal patterns we know. For example, like I want to use the banking sector, which is quite different from what I'm talking about. In the banking sector, maybe we have a data of someone's finances for the last 6 months since he has been in since he opened that account. Maybe the highest transaction he has made was between £5 to £600, and all of a sudden we're seeing a transaction of around £10,000 at odd hours. That's an anomaly. We have a data, and all of a sudden we're seeing something different from what we understand. So we could include anomaly detection in real time to ensure that these devices are monitored, thereby leading to a strong security for our embedded devices. What are defensive measures we could adopt? One of them is AI-driven anomaly detection, which I just explained. That's like using machine learning. So machine learning, we can train this data over time. So it recognizes a pattern. So it sees something that is usual from what it knows. It spots it and knows that this is like a cyber threat or a cyber attack. Then the hardware root of trust method, which I talked about earlier also. So we could secure our hardware architecture so that only authenticated devices can operate within the system. Only verified devices can operate within the system, such that any system that is not connected, it can't operate within the system, and thereby we could limit these cyber attackers' access to sensitive data. Another one is we could regularly secure and encrypt our firmware updates, and this would also help to reduce or prevent unauthorized access to our embedded devices. Now, what are the future trends in embedded security? The first one is AI will enhance real-time threat detection, adapting defenses in response to evolving attack patterns. So there's a lot of things going on right now in the AI industry. So with the use of machine learning, we're training models. We train models to recognize patterns. You understand? We recognize patterns, and by recognizing patterns, we could judge a legitimate data from a one that is fraudulent or it's not authorized. Also, things like quantum-resistant cryptography is being developed to prepare embedded systems for future quantum computing threats. There are also emerging standards that are coming up. The National Institute of Standards and Technology, NIST, and the European Union Agency for Cybersecurity, they are driving improved security practices in Internet of Things and robotics. Now, what are the practical take-homes for engineers or developers and security professionals? One of them is we should try to implement secure coding and conduct regular vulnerability assessments. By this way, we'll be able to reduce access to these cyber attackers. Also, we should prioritize device firmware updates and use secure libraries. For security professionals specifically, our advice would deploy more monitoring systems to detect anomalies, create incident response plans, for Internet of Things and robotics setups. Now, as I conclude today, while there is an increase in technology, we also need to balance the security side of things so that as we're evolving, the security side is also getting tightened such that the future is safe and we have more secured embedded devices, and that's it for me. Thank you.
Are you wanting
Does
to...
anyone have any question? Okay.
Oh, pass this down, so just so it goes on recording. Is there a space for education in solving this, in that you're teaching boards and executives that secure devices is good, and also teaching engineers what does good security look like? Or do they get taught that now?
I don't really get your question.
Is education a gap in that engineers don't know how to do secure design? It's not that they don't want to do secure design; they just don't know that it's insecure. But or do they know what secure design is? But it takes longer, and the executives don't want them to spend time on it because it doesn't earn them any more money.
Answer on the
I think one of the problems is actually education is part of it. Many with the rise of technology today, there's a lot of advancements in technology. Is the reason for this talk. So we want to try to balance it, you understand? While there's a rise in technology, we also need to, because these devices, they are sophisticated, you understand? Sophisticated, and because of their nature, they are kind of like, they are poorly secured. So we need to balance the rise in technology with security. So that's why this event is a good event, because it brings together professionals from different fields, and we're able to share ideas and try to adopt strategies to mitigate these cyber attacks.
Anyone else? No? In that case, thank you very much indeed, Victor.
Yeah, thank you.